Solid Edge has an integrated design environment that allows you to apply ordered features to synchronous models. Synchronous modeling provides a perfect foundation for accelerated design, faster edits, and handling imported data, and allows ordered features for process type parts. Here we're going to start modeling an engine cover. By simply selecting a region, we can drag this out into a 3D model. Next, we'll add some rounding. Sketches can be created in 3D space, or they can be directly applied to a 3D face on a model. Here we need to remove some material around these brackets. When selected, closed regions display a handle, and a quick grab and go turns them into a 3D feature. Pulling regions adds geometry, and pushing it removes material. With fewer commands to learn, new users adopt Solid Edge faster, and experienced users design more efficiently. Next, we'll mirror this to the opposite side. Working top-down, adjacent parts can be used as a guide, ensuring parts fit together as you design. Here we're going to match the front of the engine cover to be parallel with the back of the seat, using the parallel relate command. Geometry creation and manipulation is simple. Select a 2D region or a 3D element and use the drag handle to edit the part to a new shape. Here we're just going to drag the top of the engine cover up 100 millimeters. Next, we're going to add some aesthetics by just adding some rounding to our part. Next, we need to create some clearance around some adjacent parts in our assembly. So by turning on the background parts, we can see the sheet metal bracket that's interfering with our engine cover. So we're just going to project with an offset the edges of the sheet metal cover so that we can ensure that we have clearance around that part of the assembly. Sketching tools like trim corner helps us quickly create a sharp corner. And now we can use that sketch to model a cutout. This is an open profile, so we just tell Solid Edge which way we want to remove material. Once again, we'll add some more rounding. We may wish to add stylized shape to the top using Solid Edge's rapid blue surfacing tools to increase the appeal of the final design. So what we'll do is transition to the ordered mode and create some ordered features on top of the synchronous body. We'll start the surface creation by creating first a guide curve. Just clicking points in space, we can create a B-spline curve. Next, we need to create the cross curve. We're going to do this with an arc at a parallel plane along the y-axis of the engine cover. Using Solid Edge's sketching tools, we'll just create a 3-point arc, and we'll use the alignment indicators to make sure that the two ends of the arc are aligned with each other. You can also connect the midpoint of that arc to the center line of the engine cover. Next, we're going to convert this from an arc to an actual B-spline curve just with a single mouse click. In order for the two curves to be able to be used to create a blue surface, they need to be connected, and with Solid Edge's blue dot functionality, we can join those two curves together regardless of the order in which they were created. Now, to create the blue surface, just simply 2 clicks. One for the cross curve and one for the guide curve. And now we'll make the top of the engine cover match the surface. Notice how the rounding is reapplied after the replace face function is used. Now we'll thin wall the part. Dimensions can be added at any point to provide precision. So in this case, we're going to create a dimension to represent the width at the front of the engine cover. Notice how as we create the dimension, it finds the theoretical intersection where the faces meet. As we modify this dimension, also notice that Live Rules maintains the symmetry in this part. You can also lock dimensions so that changes made from the outside with a push or a pull doesn't change that dimension. Here we're going to add an angle or add some draft to this front of this engine cover. Just by rotating the face, you can see that it remains symmetric based on Live Rules. We'll also add that same angle to the sides of the engine cover. And then finally, we may need to add some clearance, or maybe just for aesthetic value, we're going to rotate the back of the engine cover as well. We can use the adjacent parts to ensure that we're inside the bracket that goes around the back of the engine cover. Ensure that it fits. Next, maybe we'll modify the shape of the surface. The guide curve is controlling the shape of that surface, and just by manipulating that curve through the edit points, we can change the shape of the engine cover itself. We can also modify the position of the blue dot, which is connecting the two curves together. This again will change the shape of the engine cover. Now as we rotate the part around, we can see that part of the engine is actually poking through the side of the engine cover. So we'll need to create some clearance in this area. Again, this is the advantage of top-down design. So we'll just go back and we'll edit that engine cover, and we're going to actually transition back to the synchronous body that's underlying the ordered features. We're going to add a cutout in the synchronous mode. We're going to create a sketch actually on the center line or the center plane of the engine cover. By creating it in the synchronous mode, we'll be able to push and pull this cutout to change its shape and size after we've finished modeling the feature. So just using sketching, we're going to sketch around the area that we want to cut away. And using the powerful rounding tools, we can just drag across the corners to connect and add the round or the fillet. Now again, this is an open profile, and we can use that open profile to create an extrusion and cut away material. We just simply tell Solid Edge which way is the enclosed volume to the inside, and that we're cutting away the material. And now as we transition back to the ordered mode, the ordered features get reapplied. You'll notice the thin wall fails. And this is because we've introduced an open face that's been isolated. We just simply need to add it to the open face select set. And once we do that, the engine cover is complete. As I mentioned, because it is a synchronous cutout, we can select the face that's underlying, the synchronous face that's underlying the model, and we can simply drag to make this cutout larger or smaller. So with an integrated design environment, Solid Edge fulfills the vision of synchronous technology for accelerated design, faster, more flexible change, and more reuse with imported data. And here you can see the final design.